Trig equations continues on from National 5, and you have to be able to work with trig equations at higher as well. Some of the equations will look very familiar to you, some of the strategies that you use will be very familiar. As we progress through this part of the topic, we will start to introduce a few new skills. So starting off with this first example on the left, we've got root 5 sine x equals to 1. Now this part here, remember that means that you're looking for values basically that lie between 0 and 360. So your x values, your final answer should lie between 0 and 360. At National 5, that wasn't too important to us. At higher, it will become a lot more important. That is something that you should be checking before you begin your trig equation. So, same as at National 5, first thing we have to do is rearrange to get into the form sin x, cos x or tan x equals something. So in this case, when we're rearranging it, we're dividing through by that root 5. So we end up with sin x equals 1 over root 5. Now the minute you get into the form sin x, cos x or tan x, so each of them without a coefficient, you can use your cast diagram. Remember, your cast diagram tells you where things are positive. So in this case, sin x is a positive 1 over root 5. We're ticking where sin is positive. It's positive in A, where they're all positive, and in S, where sin is positive. We can now continue to solve for our calculator answer. So remember, to find the value for x, we do sin inverse. So it's going to be sin inverse of 1 over root 5, stick that in your calculator and you get 26.57 if you round it to 2 decimal places. So that gives you your calculator answer. That 26.57 would lie in your A quadrant. We've also got this S quadrant ticked. So remember, to find values in that quadrant, you're doing 180 minus your calculator answer. So minus that 26.57. So our two values of X are 26.57 and 153.43. So these are our two answers. Just a quick double check. They both lie between 0 and 360. So I'm happy that we don't need to exclude any of them from our solution. Moving on to this next one. So this one's slightly new again because we have our restriction in radians. So remember, pi is 180. So we're looking for our final answer, our x values, to lie between 0 and 180. Now that is particularly important in this question. As we progress through the course, this 2x here will mean something a little bit more to you. So this we will expand on, but for just now, we're going to kind of just brush over it. So a lot of you would have realised that in class the teachers had said that we were going to come back to this. Maybe we've missed this example out. Maybe some of you have even seen the full solution for this, but just be aware that this might differ from what you've done in class. So similar to the first example, we want to get it into the form tan x equals something on its own. So we don't want any coefficients on it. We don't want that negative tan x. So I'm going to start by taking away 4 from both sides. That gives us negative 1 equals negative tan 2x. That negative on both sides, we can essentially just drop that to get tan x equals 1. That's us got our tan x line, so that is our cast diagram line. The minute you get tan x, sin x or cos x on their own, you can use your cast diagram. Tan is a positive 1, therefore we're ticking A where they're all positive and T where just tan's positive. Now, that 2x, we do treat it a little bit differently. So when we're looking for our x values, to start off with, we're actually looking for 2x. So 2x is going to be tan inverse of 1. Now, important in this question, the question references radians at the start, which I've already mentioned. That means that your answers should be in radians. Now, again, depending on who's teaching you this, you might find some teachers tell you to work in degrees, then change it to radians. Maybe some of you are just doing it from radians throughout. There's various different ways that you can do it. You do whichever way you're most comfortable with. However, if the question asks or gives you a restriction in radians and you don't give an answer in radians, you will lose silly marks in that one. So make sure that your final answer is in radians. So for that reason, I'm just going to do my full solution in radians. So tan inverse of 1 is 45 degrees and 45 degrees is pi over 4. Remember, if you were working in degrees and you wanted to figure that out, to change 45 into radians, you times it by pi over 180. So you would have 45 pi over 180. 45 fits into 45 once, 45 fits into 184 times, and that's where that pi over 4 is coming from. We have also ticked this T quadrant. So remember, in your T quadrant, you do 180 plus your calculator answer, or in this case, we're doing pi plus your calculator answer. That's then going to give us pi over 4 and 5 pi over 4. Right, remember at this point we have 2x. So to find x, we are going to have to divide our answers by 2. So we'll get pi over 8 and 5 pi over 8. And that's our final answers. Now, as I've said, that 2x, there is something more that you have to do to be able to work with that. However, because the restriction on this is pi, this would be your final answers, whether you've done that extra something or not. But we will come on to that in a later lesson. So this final example, so we've got 3 tan squared x equals 12. This we should be able to work with. However, there is one really important stage that we wouldn't have necessarily always thought about back at National 5. So first thing we're going to have to do is aim to get tan x on its own. So to start off, I'm going to get tan squared x on its own. To do that, I'm dividing both sides by 3. So I end up with tan squared x is equal to 4. We don't want tan squared x, we just want tan x. So we can square root both sides to find the square root of 4. The square root of 4 we know is 2. However, at higher, it's plus or minus 2. Right, so it's plus or minus. So you have to make sure that you're accounting for that. You have to include that minus, because 2 times 2 gives us 4, but so does negative 2 times negative 2. So you have to make sure that you're accounting for that. So tan x on its own means that we can go into our cast diagram. When tan is positive, we would tick A and T. When tan is negative, we would tick S and C. So we're looking for 4 answers for this, because essentially we've got tan x is equal to 2 and tan x is equal to negative 2. And for both of them, we would find our answers. Now, looking back up at our restriction, we are looking for answers that lie between 0 and 360 degrees. So that means that we're looking for solutions in degrees. So we can just work with degrees. We can use our calculator for it. So x equals tan inverse of 2. So remember, you don't put negatives into your calculator following an inverse function. If you do that, you'll end up getting solutions all mixed up. Some of them will be right, but not all of them will be. So stick on the safe side, always just put tan inverse of the positive 2. When you put that in your calculator, you get 63.4. And our cast diagram will then compensate for our lack of putting the negative in the calculator. So for the S quadrant, we do 180 minus our calculator answer. For the T quadrant, we do 180 plus our calculator answer. And for the C quadrant, we do 360 minus our calculator answer. When you figure them all out, you get 63.4, 116.6, 243.4 and 296.6. All values lie between 0 and 360, so that's our final answers.